In this video, we will consider the derivative of this very complicated function involving a quotient, a product, and powers, and very complicated function. Hypothetically, this could be done using the techniques from Cal 1. You can apply the quotient rule, then apply the product rule, then the chain rule as needed. If you want to tackle that problem that way, good luck. It's very, very complicated to try to keep all of the powers and rules straight. However, it can be done that way. Instead, what I'm going to recommend is that we apply the logarithmic differentiation. So the first thing that we're going to do is take the natural log of both sides. The natural log of g of t will equal the natural log of, and let me just recopy the right-hand side here. Okay, now I'm going to slowly decompose this using laws of logarithms. If you're able to go straight to the punchline in one step, you're more than welcome to do so. But for the purposes of this review, I will take this slowly. First, I see I have a natural log of a quotient. So that means I get the natural log of the top minus the natural log of the bottom. Okay, for the moment, I'm going to keep that first term unaffected. Natural log of a product is the natural log of a sum. So this becomes natural log of 2t plus 1 to the fourth plus natural log of the square root of 3t minus 4. And then I use the power law logarithm. So this 3 will come down. This 4 also comes down. And this is a raised to the 1/2. It's a square root, so the half comes down. And this minus is there because minus times a plus makes a minus. So natural log of 3t minus 4. All right, now, as I said, if you're able to take the natural log of this in your head and go directly to this, terrific. I have no complaints with that at all. For the purposes of the video, I wanted to make sure I took my time going through the steps. Okay, now I apply the calculus. I take the derivative of both sides. On the left-hand side, the derivative of natural log is 1 over g of t times the derivative of the inside, which is g prime of t. And I remember that g prime of t is the thing that I'm trying to solve for in the first place. On the right side, I take the derivative, so 3 over t. And then the next term is 4 over 2t plus 1 times the derivative of the inside, which is 2. And then minus 1/2 times 1 over 3t minus 4 times the derivative of the inside, which is 3. And so simplifying, we get that 1 over g prime of t over g of t is equal to 3 over t minus 8 over 2t plus 1 minus 3/2 times 1 over 3t minus 4. And I could simplify that as well. I'll do that in the next step. Now, the point is to solve for g prime of t, so I can multiply up. G prime of t is equal to g of t times everything on the right-hand side. So 3 over t minus 8 over 2t plus 1. And then just for the sake of simplifying, 3 over 6t minus 8. And now to finish the problem, g of t was originally equal to this, and so I just make that replacement. Everywhere I see the g of t, I just make that replacement down here. So I have the original t cubed over 2t plus 1 to the fourth times the square root of 3t minus 4 times 3 over t minus 8 over 2t plus 1 minus 3 over 6t minus 8. And so that is the derivative using logarithmic differentiation, which would be a whole lot faster than attempting to use the quotient rule or the product rule and those other rules that we learned in Calculus 1.